Assalamu alaikum everyone. Second day of the virtual online classes. And what else? Yesterday we have done a topic of inclined planes. So those of you who couldn't join yesterday, they can see the same topic on the YouTube, right? I already shared the link. Anyway, so let's begin. It's your lecture number 2 of this session. So what is the AGU today? Very, very brief revision, then numericals, as I told you yesterday, right? So yesterday we did this topic, inclined plane. So any surface which is raised to at certain point and can be used to transfer heavy objects from one point to another. This one is called what? This one is called an inclined plane. So this was the definition that we have studied yesterday, that an inclined plane is also known as a ramp. It's a flat supporting surface tilted at an angle, as you have seen, with one end higher than the other, and it is used to transfer heavy objects from lower part to the higher part. All right. And then we have gone through the derivation for this equation. A is equal to g sine theta. As I told you yesterday that we'll be using this equation A is equal to g sine theta in our problems. So let's see the connected problems of our book. This is the problem. As I told you, you should have what? The calculator with you. So what is the situation here? That a cyclist is there, which is going up a slope on an inclined plane. And what is the angle of inclination here? 30 degree. Means the object is like this. The flat surface is like this, and a cyclist is moving up, right? And what is the speed of the cyclist? 3.5 meters per second. Now what he did? He stopped pedaling at once. You are going, the cyclist is going up his slope with certain speed, and then he stopped pedaling at once. What will happen? Obviously, the cycle will stop after covering some distance. So what is the question over here? What is the question over here? What is the question over here? That how much distance should be, how much distance has he covered, right, before he come to rest? So what is the scenario over here? A cyclist is going up, and what is the angle of inclination there? 30 degree. And what was the speed of that cyclist? 3.5 meters per second. And what he did, he stopped pedaling. So what happened? He will be stopped after covering some distance. So we have to find out how much distance has he covered before he coming to rest. So what do you think what the data is? Think in your mind for 15 seconds. Let's see the data. So what is the angle over here? 30 degree. And it's the speed of the cyclist, 3.5 meters per second. Since he stops pedaling, he would be stopped. And since he is going up, that is why we'll take the value of g minus 9.8 meters per second square. We have to find the distance. All right. Read the question again. See the data. And one more thing, you're sitting there, the frictional force is 0, right? Okay. Now to find distance, we have two formulas. One, S is equal to VIT plus half AT square. And the second one is 2AS is equal to VF square minus VI square. Since there is no T, we can't use S is equal to VIT plus half AT square. So the only formula left is 2AS is equal to VF square minus VI square. It means we should find first acceleration, right? We have to apply the formula 2AS is equal to VF square minus VI square to find the distance S, but acceleration is not given in the data. So that is why we should first find out acceleration. Now, to find acceleration on a on an inclined plane like a slope, we use this formula A is equal to G sine theta. Substituting the values, the value of G is minus 9.8, sine, and the angle is 30. Sine 30, what is the value of sine 30? 1 upon 2 or 0.5. So when we multiply these two, the acceleration we got the acceleration what? Minus 4.9 meter per second square. Simple. Okay. So from the data, we came to know that we have to find distance. To find distance, we will use the formula 2AS is equal to VF square minus VI square. But there is no A in it. So we have found first the value of A. Clear? Okay. Now we'll apply the formula. Now find the distance by using 2S is equal to VF square minus VI square. We will rearrange it since we have to find S. So A and 2 are useless there. So we will transfer them to the other side. So it will become S is equal to VF square minus VI square upon 2A. Clear? Now we substitute the values. What is the value of VF? Check the data. 0, 0 square minus, what is the value of VI? 3.5 square, 2 into 4.9, minus 4.9. Now, the square of 0 is 0. The square of 3.5 is 12.5, 12.25. And when we multiply 2 by minus 4.9, so subtracting So we're subtracting 12.25 from 0, we get minus 12.25 divided by minus 9.8, minus cancel. Dividing 12.25 by 9.8, we'll get what? S is equal to 1.25. Okay. So we have found that he just covered 1.25 meter before coming to rest. I hope you have understood. The data. The car is going up with an initial velocity of 63 km per hour. Angle is 45 degree. Stops paddling, VF is equal to 0. Same sort of data. So see the data over here. Initial velocity 63 kilometer per hour. So we should convert kilometer per hour into meter per second as you have done in your previous class. You know that there are 1000 meters in 1 kilometer. So whenever we want to convert kilometer into meter, we multiply by 1000. That is why we multiply here 63 by 1000 so that it would be converted into meters. Secondly, we have to convert hours into second. So there are 60 minutes in each hour and 60 seconds in each minute. So if you want to convert hours into seconds, recall, you know it. Yes, you have to multiply the number by 60 into 60. 60 into 60 means 3600. Okay. So here, simplifying it, we'll get 17.5 meter per second. All right. Again, the value of g is 9.8. We have 0. S is equal to question mark. So let's find the acceleration as we did in the previous problem. Okay, done. Now we'll find the distance. Using the same formula, same method. The value of VF is 0. The value of VI is 17.5. We'll substitute them. And 2 multiplied by 6.928. Finding their squares. The square of 0 is 0. 17.5 square is 306.25. And then we will multiply these two. We'll get minus 13.857. Subtracting. Minus minus cancel. And the distance has come out 22.10 meter. So what will you do next? Again, the numericals. 2 more numericals we'll do tomorrow. One with the same concept in inclined plane, and the other one is of momentum.